The mouse. Not this mouse. This mouse.
We didn't give much attention to it, but for all we know, it helped us translate and direct our thoughts to our computers. Literally. Optical mouse. We use it in the office and at home. We use it to prepare documents, edit photos and publicity materials, or even play games. They come in different shapes and sizes, in different designs, but they all do one thing: bridge our mind to the infinite possibilities the computers hold. Join us in unraveling the mysteries of the optical mouse. Let's reverse engineer it.
So this is what the underside of the mouse looks like. There's the optical part, and then there are the screws. We first remove the rubber covers and then begin unscrewing.
The scroll wheel, attached to the body of the mouse, generally placed in the center of the click buttons, provides additional features such as page scrolling and zooming in or out. The part is made through injection molding, similar to what the following video displays.
The shell that houses the assembly is also done via injection molding.
How are wires made? Metals are first molten under high temperatures until they flow into molds. They are then cooled off to a manageable temperature and sent to giant electrolysis baths to shed impurities. They come out as sheets of metal. Once clear of impurities, they are again molten and shaped into wires via extrusion or drawing until the necessary diameter is met. The lead solder is made through continuous drawing from a thicker lead wire as shown. A circuit board can also be found in the optical mouse. Its production starts with selecting the board, which is usually phenolic, a PCB laminate material. Fabrication starts with etching, the process of chemically removing unwanted copper from the plated board. Next is putting the pattern on the board using direct draw approach with resist pens or specialty tapes. Next, it is exposed to ultraviolet light in a UV exposure box. Then the sensitized photoresist is removed in order to protect the board from unwanted elements. This process is called developing. Next, tin plating is done for easier soldering and is essential for mounting purposes. The drills are manually drilled, and the last part is the soldering, which is the fastening of the parts to the PCB. First, a resistive region is formed over the top of a substrate. Resistor modules are formed by forming trenches from the top side of the substrate and scribe line regions where the wafer is separated. Contact layers formed over the top side of the substrate are electrically coupled to each end of the resistive region. Resistor modules having sidewall contact regions are also created by forming contact layers over trench sidewalls. How are LEDs made? They emit light by electronic excitation rather than heat generation. Diodes are made of thin layers of semiconductor material. One layer will have an excess while the other layer will have a deficit of electrons. This difference causes the electrons to move from one layer to another, thus generating light. These semiconductor layers are usually made of gallium arsenide and are grown in high temperature and high pressure chambers. The heat and pressure liquefy the metals, so they are forced into a solution. The solution is then allowed to cool and crystallize. Impurities to create electron density are added to the surface through the process called liquid phase epitaxy. In this technique, impurities are deposited on the semiconductor while it is drawn under reservoirs of molten metal. Next, the diodes are mounted on two metal leads. Usually, the semiconductor is coated with metal and forms electrical contact with the lead it rests on. A gold wire is soldered to the other lead and wire bonded to the surface of the die. Finally, the whole assembly is sealed in plastic, suspended inside a mold, which is usually a semicircle, and filled with liquid plastic or epoxy. The anode foil, cathode foil, and electrolyte paper are cut from the source rolls. The leads for contacting the foil electrodes are attached by crimping or ultrasonic welding. The electrolytic paper is layered between the anode foil and the electrode foil. The structure is then coiled into what is known as an element. This element is then filled with the electrolyte using vacuum method. The rubber plug is then attached to the filled element, and this element is placed in the case. The case is lit into a sleeve, which is then heated shrunk onto the case. A voltage is then applied to grow, and the anode oxide thin film is cut on the surface.
The screw locks the shell in place. Screws are generally produced by a thread rolling method because other methods take more time and are more expensive. Before thread rolling, cold heading is done first. In this process, a wire is fed from a mechanical coil through a pre-straightening machine. The straightened wire flows directly into a machine that automatically cuts the wire at a designated length and die-cuts the head of the screw blank into a pre-programmed shape. Once cold-headed, the screw blanks are automatically fed to the thread cutting dies from a vibrating hopper. The hopper guides the screw blanks down a chute to the dies, while making sure they are in the correct feed position. And that is how the parts of an optical mouse are made.